Right, okay. So this is question 7 on the whatever paper it was. Okay. Right. The functions f, g, and h are defined for all real values of x by these 3 things. F of x is modulus of x, g of x is 3x plus 5, and h of x is ggx. That's very good. Fitting on the day after the Grand National. Rubbish, isn't it, that joke? Right, solve the equation f of x plus 2 equals f of minus 12. Well, this bit, remember with the... Did you just get it? I get it, yeah. Remember this bit here, this tells you what you're inputting into the function. So this says into g, we're inputting x plus 2. That means we're replacing x with x plus 2. So that's part 1. We're going to write here that we've got 3x plus 2 plus 5. And that's going to be equal to f of minus 12. Well, f of x is the modulus of x. So that is the modulus of minus 12. And actually it's really simple, isn't it? That the 3 marks are really for working out what the question is asking you to do. If we just tidy this up a bit, we've got 3x plus 6 plus 5 there. And of course the modulus of minus 12 is 12. If in doubt, if you've got a Casio FX83 GT Plus, you've got the button that says ABS. And if you do ABS of minus 12, it gives you the answer 12. Fantastic button. Great. So altogether we've got 3x plus 11 is 12. So 3x is 1. And x equals a third. And what a start that is. I love having 3 marks for doing something like that. Okay, now part 2 is perhaps a little bit more confusing. Part 2 says find the inverse of h, and h is g of x. Right, well I think we need to work out, before we can work out the inverse of h, I think we need to find out h of x in terms of x, don't we? So the first thing to do is this. Now this is this bit about composite functions. And actually it doesn't matter because it's the same letter. But what this means is you do the right one first, and you work from right to left. So this is g of x. And g of x was 3x plus 5. So it's g of 3x plus 5. And that means now our input into function g is 3x plus 5. So that's 3 times the input, 3x plus 5, plus 5. That's what g of x was defined as being. And so we're going to tidy this up to get 9x plus 15 plus another 5. So, after a bit of working out, h of x was 9x plus 20, and the question said find the inverse of h. So what we're going to do is we're going to let y equal 9x plus 20. We're going to rearrange this until it says x equals, we just did one of these, y minus 20 is 9x, so y minus 20 over 9 is equal to x. Now we swap our x and y's round to get y equals x minus 20 over 9. So our inverse of h, because that's what h was, remember, our inverse of h is x minus 20 over 9. Okay, and it's defined for all real values. The original was defined for all real values, so there's no problems with the domain or anything. This would just be for all real values. And it's good practice to, whenever you're defining a function or its inverse, to say what the domains. In this case, you probably wouldn't have got any credit for doing that, but it's there. The last part says, determine the values of x for which x plus f of x equals 0. Okay, so again, we're doing, just trying to take what the question, what the original functions were and interpret what the question's asked. So that's x plus the modulus of x equals 0. So x plus the modulus of x is 0, which could also be written as being the modulus of x is equal to negative x. And it says determine the set of values for which this is true. Well, if we think back to the graphs that we know about of these things, the modulus of x is a graph that goes like that, and y equals minus x is a graph that goes, I missed slightly, but you know the idea. It goes like that. That's a terrible drawing. So what is the set of values for which these two things are the same? Well, it's all the values less than or equal to 0, isn't it? So that would be our solution. That is the set of values of x, for which x plus f of x is equal to 0. Oh, yeah, and that's very good stuff.